March 16, 2026. 6 hours ago, something happened that every scientific model currently running on Earth says should be impossible. Sensors across the northern hemisphere recorded a magnetic event so unusual that the headquarters responsible for the World Magnetic Model in Boulder, Colorado, could not classify it. At exactly 8:42 UTC, three completely independent systems triggered at the same moment: the European Space Agency's Swarm Alpha satellite, NASA's Themis mission, and the Intermagnet Observatory located in Fairbanks, Alaska. When analysts compared the readings, the probability of what they detected occurring naturally was not low or unlikely. According to every simulation currently running in laboratories around the world, the probability is exactly zero. The reason is simple and deeply disturbing. The object known as 3I Atlas has anchored itself directly to Earth's magnetic North Pole. At the same time, compass needles across the planet from London to Tokyo began rotating in perfect synchronization with that object's movement. A spinning compass needle might sound like a curiosity. In reality, it represents a civilizational emergency. To understand why, we need to look at what Earth's magnetic field actually is and what it means for an external object to interact with it, with the force levels now being recorded by three independent detection systems operating at different altitudes. Earth's magnetic field is created by the geodynamo, a massive engine deep inside the planet. Liquid iron circulates in the outer core due to heat and chemical differences, and Earth's rotation organizes that motion into spiral flows through the Coriolis effect. This movement generates a magnetic field that extends outward from the core, through the mantle and crust, beyond the atmosphere, and into space where it forms the magnetosphere. The magnetosphere is not a simple bubble. On the side facing the Sun, it is compressed to roughly 60,000 kilometers. On the night side, it stretches into a long magnetic tail that reaches hundreds of thousands of kilometers into space. This structure is Earth's main defense system. It shields the atmosphere and surface life from the solar wind, a constant stream of energetic charged particles emitted by the Sun. Without this protection, Earth would slowly lose its atmosphere. We know this because it already happened on Mars. When Mars lost its internal magnetic dynamo around 4 billion years ago, the solar wind gradually stripped away much of its atmosphere, leaving the cold desert world we see today. But a magnetic field does more than protect. It also connects. When two magnetic systems come close to each other, they can interact through a process known as magnetic reconnection. In this process, magnetic field lines break and reconnect, releasing enormous amounts of energy. Solar flares and coronal mass ejections interact with Earth this way, producing geomagnetic storms and auroras. These events can release more than 10 to the 23rd joules of energy. However, magnetic reconnection is chaotic and short-lived. It releases energy quickly and then stops. What scientists detected today is not reconnection. At 5:30 UTC, the Cluster 2 mission identified something never before recorded in magnetospheric physics, a flux tube, a stable channel of magnetic field lines forming a direct connection between Earth's magnetic North Pole and the location of 3I Atlas, nearly 240 million kilometers away. This is not a diffuse region of interaction. It is a defined structure, a magnetic highway stretching across interplanetary space. Inside this channel, the measured energy density is approximately 10 to the 16th joules per cubic meter. That amount of energy is comparable to detonating a 1 megaton nuclear warhead every second, focused continuously into a beam roughly the width of the U.S. state of Rhode Island. According to Maxwell's equations, the mathematical foundation of electromagnetism, developed by James Clerk Maxwell in the 1860s, such a magnetic structure should be catastrophically unstable. Magnetic field lines behave like stretched elastic bands. They naturally collapse and reconnect to release energy. Maintaining a coherent flux tube across 240 million kilometers while resisting the solar wind, the interplanetary magnetic field, and Earth's own rotation requires constant energy input. The estimated power needed to maintain this connection is about 400 terawatts. That is roughly 20 times the total electrical power currently consumed by human civilization. And it is being produced by an object less than 10 kilometers wide. Spectroscopic surveys conducted in January 2026 offer the first clue as to how this is possible. Normal comet nuclei are mixtures of water ice, carbon dioxide ice, silicate dust, and organic compounds, essentially debris left over from the early solar system. But 3Thursday Atlas is different. Its surface spectroscopy revealed concentrations of ferromagnetic metals, iron, nickel, and cobalt, at levels 10,000 times higher than any comet ever catalogued. In other words, this object is not a frozen snowball drifting through space. It is a highly magnetized metallic body. And as it moves through the interplanetary magnetic field at 68 kilometers per second, it interacts with that field through magnetohydrodynamic forces similar to those studied in fusion reactors and solar plasma physics. This is not passive comet behavior. It is active electromagnetic engagement, and the probing phase had already begun hours before anyone realized what was happening. The probing phase began long before the magnetic anchor locked into place. At 3 UTC, 5 hours before the event that would trigger alarms across the scientific community, the Swarm Alpha satellite detected a sudden spike in magnetic intensity directly above Earth's north pole. The increase measured roughly 400 nanoteslas and occurred in just 3 seconds. On its own, that might have been dismissed as a minor fluctuation. But NASA's Themis mission recorded a matching distortion inside Earth's magnetotail at exactly the same moment, and the Intermagnet Observatory in Fairbanks confirmed both signals simultaneously. 3 independent systems had detected the same anomaly. This was not noise, it was a scan. 3I Atlas was mapping the geometry of Earth's magnetic field. At 8:30 UTC, moments before the anchor formed, something even more extraordinary happened. The object's rotation stopped. Prior observations showed that 3I Atlas was spinning rapidly, completing a rotation roughly every 23 minutes. Its equatorial surface was moving at nearly 2,000 miles per hour. Yet in less than 3 seconds, the rotation halted completely relative to Earth's magnetic field, stopping an object with a mass estimated at 33 billion tons, and that level of angular momentum should produce enormous mechanical stress. The deceleration required would generate forces measured in the millions of Gs. Any natural object would fragment instantly under those conditions. But the radar return from the Goldstone Deep Space Communications Complex showed no debris field, no fragmentation, and no structural collapse. The object simply stopped, aligned itself perfectly with Earth's magnetic pole axis, and remained fixed in that orientation. From that moment forward, the compasses across Earth were no longer pointing only toward our own magnetic pole. They were responding to a second one. Compass needles began rotating with a period of 23 minutes, the exact rotational period previously measured for 3I Atlas. The signal from the object was now traveling through the magnetic flux tube and entering Earth's field with enough strength to compete with the geodynamo itself. This was not interference. It was synchronization. Then another signal appeared. At 8:15 UTC, before the anchor fully formed, the HAARP research facility in Alaska detected a radio carrier wave traveling down the flux tube at 2.8 MHz. The signal was not random. It carried a modulation pattern with a ratio of 0.618. The golden ratio. This mathematical proportion appears throughout natural structures, from the spirals of nautilus shells to the arrangement of sunflower seeds and even the geometry of spiral galaxies. Nature produces it in growth patterns and physical structures. But nature does not broadcast it intentionally on a specific radio frequency aimed at a planet's magnetic pole. And when the magnetic anchor locked at 842 UTC, that signal changed character completely. The moment the magnetic connection stabilized, the signal stopped behaving like a simple carrier wave and began transmitting structured data. Within 11 minutes, the Dominion Radio Astrophysical Observatory in Canada decoded the shift. The original sine wave modulation vanished and was replaced by a complex digital pattern that never repeated. At the same instant, the transmission speed surged from 0 to 400 gigabits per second. To understand how extraordinary that is, consider the global internet. Thousands of fiber optic cables spread across continents and oceans together move roughly 500 terabits of data each second. 3I Atlas was transmitting nearly half a terabit through a single magnetic connection directly into Earth's ionosphere. This was not a greeting, it was a scan. SETI Institute cryptographers quickly began decoding the incoming stream. What they found shocked them. The transmission was not composed of prime numbers, geometric sequences, or any of the mathematical greetings scientists often imagine extraterrestrial civilizations might use. Instead, it contained Earth's own environmental data, real-time atmospheric readings, ozone concentration over Antarctica, nitrogen density in the upper atmosphere, measurements of magnetic field strength at the core mantle boundary thousands of kilometers beneath Earth's surface. The object was reading the planet and transmitting the results. To understand how that is possible from a distance of 240 million kilometers, scientists turn to magnetohydrodynamics, the branch of physics that studies electrically conductive fluids moving through magnetic fields. Swedish physicist Hannes Alfvén developed this field in the 1940s and later received the Nobel Prize for the work. In magnetohydrodynamics, a flux tube is more than just a bundle of magnetic lines. It acts as a physical channel through which energy and information can travel as Alfvén waves oscillations that propagate along magnetic field lines. These waves can carry both momentum and data across enormous distances. In natural conditions, they transfer energy from the solar wind into Earth's magnetosphere. But the flux tube connecting 3I Atlas to Earth is unlike anything previously recorded. It stretches 240 million kilometers, and the energy maintaining it 400 terawatts is the same structure carrying the data stream. The cable and the power source are one and the same. The flux tube is both transmission line and energy conduit. If the power sustaining this structure came from the solar wind, the physics would at least make sense, but the next data point eliminated that possibility completely. At 6:15 UTC, the ACE spacecraft positioned at the L1 Lagrange point detected a sharp drop in solar wind density. The flow of charged particles from the Sun briefly approached zero as solar activity dipped. If 3I Atlas were harvesting energy from that wind, converting its kinetic energy into electromagnetic output, then the strength of the magnetic anchor should have dropped as well. Instead, the opposite happened. At the exact moment the solar wind weakened, the flux tube's intensity increased by 14%. In other words, the power output rose precisely when the external energy source disappeared. That violates every passive energy harvesting model known in physics. The power is not coming from the sunday. It is not coming from the solar wind. And it is not coming from any external environment. It is being generated internally inside a metallic body less than 10 kilometers wide. At 7:45 UTC, another anomaly appeared. The Jet Propulsion Laboratory's Horizons tracking system detected a tiny shift in the object's trajectory, just 0.004 degrees. Small, but physically impossible. The shift occurred perpendicular to the Sun object line, which eliminates solar radiation pressure as the cause. It also rules out the Yarkovsky effect, a force caused by uneven thermal radiation from rotating bodies. Only one mechanism fits the observed motion. The Lorentz force, the force experienced by a charged object moving through a magnetic field. For that force to alter the path of a 33 billion-ton body, the object must carry an electric charge of roughly 500 coulombs per kilogram. Any natural metallic body holding that much charge would tear itself apart instantly from electrostatic repulsion. Yet radar data from Goldstone showed the object perfectly intact. Whatever material holds three I-Atlas together has no known equivalent in human science. Then the transmission changed again. At 9:15 UTC, the atmospheric scan ended and a new signal replaced it. This time the pattern was unmistakable. A descending sequence of prime numbers beginning at 17,389. With every pulse, the number decreased by exactly 1. Even more remarkable, the pulses were synchronized with nanosecond precision to the United States Naval Observatory's primary atomic clock in Washington, D.C. Not to GPS satellites, not to any public broadcast, to the master clock that defines official U.S. time. 3. I-Atlas had somehow locked onto Earth's most precise timing signal and incorporated it into the transmission itself. When scientists calculated the rate of the descending sequence, they found something chilling. The countdown would reach 0 in exactly 48 hours from the moment of detection. NASA disconnected the public Deep Space Network data feed at 9:20 UTC, but amateur radio operators across several continents continue to receive the signal. The prime numbers are still descending, and another transmission is occurring simultaneously. At 8:50 UTC, the Green Bank telescope in West Virginia detected a narrowband radio beam leaving 3I Atlas and traveling away from Earth toward the center of the Milky Way galaxy. The object is not transmitting to Earth, it is transmitting through Earth. The magnetic flux tube acts as a planetary sensor array, using Earth's own magnetic field to gather data about our planet's atmosphere and interior. That information is then sent outward through the secondary transmission toward a destination roughly 26,000 light-years away. While the countdown continues, and while no agency on Earth has publicly explained what happens when it reaches 0, Part 5. Then the transmission changed again. At 9:15 UTC, the atmospheric scan ended and a new signal replaced it. This time the pattern was unmistakable. A descending sequence of prime numbers beginning at 17,389. With every pulse, the number decreased by exactly 1. Even more remarkable, the pulses were synchronized with nanosecond precision to the United States Naval Observatory's primary atomic clock in Washington, D.C. Not to GPS satellites, not to any public broadcast, to the master clock that defines official U.S. time. 3. I-Atlas had somehow locked onto Earth's most precise timing signal and incorporated it into the transmission itself. When scientists calculated the rate of the descending sequence, they found something chilling. The countdown would reach 0 in exactly 48 hours from the moment of detection. NASA disconnected the public Deep Space Network data feed at 9:20 UTC. But amateur radio operators across several continents continue to receive the signal. The prime numbers are still descending, and another transmission is occurring simultaneously. At 8:50 UTC, the Green Bank telescope in West Virginia detected a narrowband radio beam leaving 3I Atlas and traveling away from Earth toward the center of the Milky Way galaxy. The object is not transmitting to Earth. It is transmitting through Earth. The magnetic flux tube acts as a planetary sensor array, using Earth's own magnetic field to gather data about our planet's atmosphere and interior. That information is then sent outward through the secondary transmission toward a destination roughly 26,000 light-years away. While the countdown continues, and while no agency on Earth has publicly explained what happens when it reaches zero, and that brings us to the question that every observatory, research center, and space agency on Earth is now asking quietly behind closed doors. What happens when the countdown reaches zero? The descending sequence of prime numbers continues without interruption. Every second, another value drops, perfectly synchronized with Earth's most precise atomic clock. The signal is stable, the timing is exact, and nothing in the transmission suggests noise, error, or random fluctuation. Whatever system is generating, it is operating with absolute control. Right now, the scientific community is divided into two broad interpretations. The first possibility is that the countdown represents a calibration cycle. If 3I Atlas is using Earth's magnetic field as a sensing instrument, the initial atmospheric scan may only have been the beginning of a much larger process. In this interpretation, the descending primes simply mark the duration of the observation window. When the sequence reaches zero, the scan ends, the data collection phase is complete, and the object disconnects from Earth's magnetosphere before continuing its journey through the solar system. That explanation is appealing because it assumes nothing more than advanced technology performing a remote survey. But there is a second interpretation, and it is the one making physicists and aerospace engineers deeply uncomfortable. In communication theory, countdowns are rarely used for passive observation. They are used to synchronize events. Every rocket launch on Earth relies on a countdown sequence. Satellites deploy instruments on timed triggers. Deep space probes activate maneuvers according to synchronized clocks. A descending sequence, ending at zero, is the most reliable way to coordinate a complex action across large distances. If the signal from 3I Atlas follows the same logic, then the countdown is not measuring the end of the scan. It is measuring the beginning of something else. And there is another detail scientists cannot ignore. The secondary transmission detected by the Green Bank telescope has not stopped. The narrowband radio beam aimed toward the center of the Milky Way continues to operate while the countdown progresses. Every packet of information gathered from Earth's atmosphere, magnetosphere, and interior appears to be forwarded outward through that beam. In other words, whatever is receiving that transmission already knows what 3I Atlas has discovered about our planet. The flux tube connecting the object to Earth is still stable. The magnetic energy within it has not dropped. The internal power generation, estimated at roughly 400 terawatts, remains constant. And the compasses across the world are still rotating slowly, responding to a second magnetic influence that now shares control with Earth's own pole. For the moment, the system is holding steady, but the clock is still ticking. At the time of this recording, less than 30 hours remain before the sequence reaches zero. Space agencies have increased observation schedules. Radio observatories are capturing every microsecond of the signal. Magnetometers across the planet continue to track fluctuations in the flux tube. Yet despite the global effort, no one can say with certainty what the final moment will bring. Perhaps the connection will vanish as suddenly as it appeared. Perhaps 3I Atlas will release the magnetic anchor and drift back into interstellar darkness, leaving behind nothing but an enormous scientific puzzle. Or perhaps the countdown marks the start of the next phase of an operation that humanity has only just begun to notice. For now, all we can do is observe, record, and wait for the numbers to reach their final value. And if you want to stay updated as scientists track the signal, decode the transmissions, and analyze what this object might actually be doing in Earth's magnetic field. Make sure to subscribe to the channel, turn on notifications, and share this video with anyone who follows space and science. The next update could arrive at any moment.